SyncHub's offering is simple. We pull raw data from your cloud services, like HubSpot or Monday.com, and we store it in a relational database for your needs. To do this effectively, SyncHub needs to be able to detect and efficiently download data as it is modified by your cloud service. Data accessibility seems simple on the surface, but is in fact packed with nuance and technical challenges. So in this video series, we're diving into the 9 most important features that our technical team considers when connecting to a new cloud service. These considerations are something we call the Data Accessibility Checklist. If you are authoring your own API, we encourage you to keep these in mind during development, in order to ensure your data is accessible to your users. So, with that in mind, let's move on to our third video, data structures. When it comes to the data structure that your API uses to return its results, to nest or not to nest is a complicated question. Consider an invoice, a common type of entity that we see with SaaS services. An invoice includes properties like date created, date completed, total cost, GST, refund status, etc. It also has child entities, like line items, with their own set of properties, product name, individual price, quantity, and so on. If a user queries the invoice's endpoint, you could return the information for all the related line items with the payload for the invoice. This is what is called a nested data structure. However, if you just returned the invoice information, and a subsequent call be required to get any information on the line items, this would be a flat data structure. So, which is best, to nest or not to nest? Let us put aside data accessibility for a moment and consider the problem from a real-world perspective. Meet Dave, a software engineer responsible for maintaining the API for his company's SaaS. Dave would like to reduce the pressure put on his services system by third-party developers. From the logs, he can see the top requested endpoints from the last 30 days. It is pretty clear to him that his customers are querying for invoice headers, then making subsequent calls to retrieve line items and customer details for each invoice. So, he decides to try nesting the data returned from his API. Now, when people query his invoice endpoint, they also get a breakdown of items and customer nested in the invoice data. Next month, his service's stats look like this. If we take the number of milliseconds as vaguely analogous to the pressure on the system, then Dave has reduced the stress on his system by almost 30%. Less server usage means less cost, so this is a big improvement for Dave's service, and likely makes the third-party developers happier now that they don't need to iterate and make as many calls. So, which is best, to nest or not to nest? Well, let's look at this from the opposing perspective of 2 third-party developers that use this API. To simplify things, let's say Francesca and Bowden both report on the same set of invoices. They have different purposes for the data. Francesca offers a service where she formats and prints invoices, so needs to get information regarding the invoices, their line items, and the customers they belong to. Initially, Francesca was making an average of 6,000 calls per day, totaling 300 megabytes worth of data that she had to pull from the API. Now, with Dave's nested structure, she doesn't need to make a separate call for the line items and customers. It all comes down when she requests the invoice info. So, she now only needs to make 1,200 calls a day to get the 300 megabytes of data that she needs. Bowden offers a real-time reporting dashboard to his customers, and generally just needs basic information on invoices such as when they were created and completed. Before Dave made his improvements, Bowden made, on average, 1,200 calls per day to request invoice data, and that's all he needed. This was about 60 megabytes per day of data that he had to pull down from the API. Now, with Dave's new nested data structure, Bowden still makes 1,200 calls per day to get the invoice information that he needs, but this is now 300 megabytes of data that he has to pull from the API. To compound matters, Bowden must get regular updates whenever line items change. Without the ability to request line items on a per-item basis, he is forced to re-download the entire payload every time, even though he only needs a small component of it. We can see from this example that nested and flat data structures both have valid use cases. So, which is best, to nest or not to nest? If you're Dave or his manager, nesting is clearly the better choice because of the way that his users are predominantly using the system for one-off queries. This change saved both his company and their third-party developers time and money. However, bringing this back into the realm of data accessibility, which aims to simplify or reduce the work required for developers at both ends. A flat data structure is best, as nested data introduces a layer of interdependence that is quite frankly unnecessary. It is better for accessibility to have each endpoint completely isolated from the others. Let's clarify why by going over some of the benefits of a flat data structure. Data requests are smaller and more granular, so if there is a problem with a particular record, it is far easier to isolate, retry, skip, etc. We have the freedom to choose exactly which data we want and when. Perhaps we don't need customer information at all, so why would it be delivered in the context of an invoice endpoint? Or maybe we do want it, but it is lower priority. Better to get the invoice info first and the customer info afterwards. Another benefit of flat data structures is with regard to modification flags, something we have covered in the first video of this series. With flat data structures, a modified line item need only flag its own record with a modified marker. However, in a nested structure, the API is invoice-centric, and thus the invoice header record needs to also be flagged as modified. A terribly inefficient flag when the majority of the invoice and its children remain unmodified. Finally, let's remember that third-party developers most often pull API information into a structured store, such as a relational database. If the incoming payload is nested, they now need to unravel and restructure the nested data to fit their flat data store, often having to fudge additional child-parent foreign keys that are generally omitted or inferred with nested responses, thus adding complexity to their work. So in summary, despite flat data structures being the best for data accessibility, Dave was right to make the changes that they did to his system. It saved him money and made life easier for the third-party developers. This is why to nest or not to nest is such a complicated question. To be a truly data accessible platform, an API needs to serve both use cases. For example, as provided by some Graph API implementations, but that's going to require a video of its own. This has been an overview of data structures, the third point on our data accessibility checklist. For more info, check out the link to our blog post in the video description, and join us next time as we dive into single item retrieval.